So this is a very simple direct conversion receiver that I threw together last weekend, mainly to experiment with Manhattan pad drill cutters that I found online. Very nice. You don't have to, I really like this this building style for rapid prototyping, for home brewing receivers, transmitters, transceivers, and it was a real pain in the butt. Aspect of it is, cutting out the pads and gluing them board. This is very simple. I invested like $40 in a Dremel drill press, and it took literally minutes to lay out and drill out the pads and start going to town. So reason I wanted to make the video is I was talking to a friend last week about filter design, high pass, low pass, band pass types of filters, and where you would use them and why you use them in receivers and the like, and other equipment. And there's one in one of the simplest receivers you possibly can build. And so I thought I'd just show a practical application of one. Here you can see that there's the antenna connection, or the input to the receiver. In this case, while it is connected to an antenna, really what I'm doing is I'm pumping in a signal from my signal generator, which is over here. The bandpass filter is designed, you can actually tweak it using those trimmer caps you can see, but right now it's the center of the pass band is designed to be about 7 megahertz, 6.95 megahertz, around there. And as you can see, there's my old school HP frequency counter, which is still very rock solid accurate. And while I'm at it, there's my one of my favorite pieces of equipment, old school Tektronix scope. But I use this one in a lot of builds now, the Rigel, because you can store different waveforms that for equipment that you've built. Very, very good when you're trying to diagnose things later on that may not be operating up to spec. So anyway, let's go on, and when I start increasing the frequency, I'm going to go by 10 kilohertz increases, and you can see the waveform start to attenuate. And that's exactly what should be happening with a bandpass filter. In this case, now I'm up to 7.05 megahertz, and finally it attenuates almost to nothing. Now if I go in the other direction and we get to the middle of the pass band, about 6.95, and we start decreasing below that, you'll see it start to attenuate again, down to nothing, past the 3 dB cutoff on each side, and so it behaves just like you'd expect a bandpass filter to behave, up and down the frequency, okay, raising and lowering the frequencies. So that's pretty much how a bandpass filter is supposed to behave. Maybe if I have more time, I'll describe the rest of the circuit in another video. The VXO you can see here with the crystal oscillator, a variable crystal oscillator. Also a very, very simple mixer, which is a single-ended MOSFET mixer. This mess over here, that's pretty much, I had extra real estate on the copper clad, so that's a muting circuit. The reason you'd use something like that is, say you want to use it with an actual transmitter. Usually you're going to put a muting circuit in there, or a TR switch. You'll do it manually, but it's cooler to use a muting circuit, so that when you key up the transmitter, automatically the receiver cuts out, so you're not blowing the doors off of your receiver, and maybe even overloading the front end if it's a more sensitive receiver. So this is and of course there's an audio amplifier, which I may talk about later too. I like that chip. First time I've used it in a build. It's not a 602. So anyway, we'll if I have more time, we'll talk more about this circuit at some other time. So that's pretty much how a bandpass filter works, and in actual operation. More later. Take care.